Part 3. Practical uses of eddy current. Eddy current flow consumes energy, but we can still make use of eddy current if we are creative enough. A. Induction cookers. When eddy current flows on the metal base of a cooking pot, the Joule heating effect of eddy current flow produces heat. An induction cooker uses thick copper wire to form coils of many turns in which high-frequency alternating current flows. The fast-changing magnetic field may produce large eddy current, which results in large Joule heating effect for cooking.
We are going to show the working principle of the induction cooker. A coil is placed on a retort stand. It is connected to an AC power supply. Put an aluminium ring through the stand and rest it on the coil. Switch on the AC power supply. Why does the ring float in mid-air? If we press the ring towards the coil, the ring will get warm very rapidly. This is due to the induced currents flowing within the ring. Such currents are called eddy currents. The same principle is applied in induction cookers. The induction cooker heats up the metal pot without any flame. It merely uses the heating effect of the current. Metal cookware should be used for an induction cooker. If a glass beaker is used instead, the water will not be heated. Why?
B. Eddy current brakes. Magnets are installed on rails to brake high-speed train or roller coasters. When metal part of the fast-moving train passes between the magnets, eddy current is induced, which consumes energy. The kinetic energy of the train is reduced, and hence the train is decelerated. C. Induction furnace. When metals are placed inside a fast-changing magnetic field, there will be eddy current flows inside the metal, which may produce large heating effect to melt the metal piece. An induction furnace makes use of eddy current to melt metals. By the way, the container is called crucible, which should not be made of metals. Why? Part 4. Other applications of electromagnetic induction. Other than applications of eddy current, there are other uses of electromagnetic induction. A. Moving coil microphones. A moving coil microphone converts mechanical vibration into electrical signal. A moving coil microphone, as its name may tell, has a moving coil which is driven by vibration of sound when we speak into the microphone. The vibration of the sound wave is collected by the diaphragm, which is a paper cone, and the diaphragm then vibrates with the cone housed between the poles of a pair of circular magnets. According to Feynman's right-hand rule, the induced current are produced to flow in different directions when the coil moves in and out of the magnetic field as shown in figure 5.3w. B. Digital pens. Digital pens make use of electromagnetic induction to capture handwriting strokes. The pen has a coil which experiences the varying magnetic field produced by the coils on the sensor board, and thus a current is induced, which in turn produces a small magnetic field. The coils on the sensor board detect the weak magnetic field produced due to the small induced current and thus detect the position of the pen. C. Hard disk. A computer hard disk usually has several rotating disks called platters, coated with magnetic material which performs like tiny magnets. When the head writes information, current signal flows through the coil in the right head and it magnetizes the magnetic materials in certain direction, say left for 1, right for 0, storing the information onto the platter. When the read head reads the information, the coil picks up the magnetic field produced by the magnetic materials and induced current is produced in the coil by electromagnetic induction. Now, please do check point 6.